Hello, Anemometer is an instrument that measures the speed of the wind. It consists of a series of caps mounted on the end of arms that rotate in the wind. The speed of which the caps rotate indicate the wind speed. In this case, the speed of rotations of the caps is proportional to the voltage on the yellow wire of this cable. This voltage ranges from 0 volt to 5 volts depending on the wind speed from 0 to 100 km per hour. Then we bring this signal to the analog input of the microcontroller. We read the current wind speed on a scale consisting of strip of 64 RGB LEDs marked in km per hours and meter per seconds. The color of corresponding LED changes from blue at low wind speeds, then to shades of green, to red and magenta at very high wind speeds. At wind speed greater than 50 km per hour, white warning LED and audible signal are activated. The device is very simple to build and contains only a few components. The following is a detailed description of the components. This video is sponsored by DFRobot. All the components used in this project are from DFRobot website. You can get all these components from the links below the video in the description. On DFRobot website you can find special electronic products with high quality and cheap price. Let me tell you that from my fans, DFRobot provides 20 special store coupons, each worth of $5. They can work together with any other coupon in their store and it's only findable in my channel. This is small Beetle CM32U4 microcontroller board compatible with Arduino Leonardo. Includes most commonly used communication interfaces like I2C, SPI, UART, 2 analog interface, 2 digital interface, 2 GND reserved and 1 5V output, which are all designed as pin connector form, more intuitive and easy to use compared with the onboard pads of Beetle. Besides, Beetle CM32U4 supports official Leonardo firmware, which means you can directly use it in an Arduino IDE without extra download. It integrates the charging management function for lithium battery. You can easily connect the battery to the board via pins, which could reduce project building difficulty, meanwhile much smaller and safer. There are 3 power supply methods: USB power supply, battery pack power supply on the BAT pin, 5V external power supply on the V-in pin, making this board more widely applicable to do-it-yourself projects. This is the flexible LED strip of 50 centimeters and composed of 166 LEDs. The lights emitted by the LED bits can be turned on to extremely uniform light of different colors after going through refraction, reflection and interaction with the phosphor in the encapsulation colloid. It supports 5V power supply, single wire control and cascade connection. LED type is SK6812 and this chip has voltage independent color and brightness over a wide voltage range, which means that the colors of the LEDs should not be affected by drop in the supply voltage. The SK6812 is very similar to the WS2812B and it can be used as a drop-in replacement in most applications because it features the same interface and color order. This is Anemometer Kit made of shell wind caps and circuit module. It has built-in photovoltaic module in the industrial microcomputer processor and standard current generator. Made with aluminum alloy, the anemometer is of high strength, weather resistant and corrosion resistant. The high quality interface ensures long life and at the same time enhancing the accuracy of wind speed acquisition. Supply voltage is DC 12 to 24 volts, output signal range 0 volt to 5 volt, effective measurement range from 0 to 30 meters per second with system error of plus minus 3% and resolution of 0.1 meters per second. Let me mention that the anemometer signal is compatible with 5 volts microcontrollers, so if we use a 3.3 volts microcontroller such as ESP32, we should also use a level connector board. The warning LED, buzzer and RGB LEDs strip are connected to the digital pins of the microcontroller. The button is used to select between line and dot mode to display the value. Arduino code is relatively simple and can be used to display the value of any sensor that has an analog output. It is only necessary to make a small change in the code based on the voltage range generated by the sensor. If the range is from 0 to 5 volt as in this case, then there is no need for any changes. The anemometer kits come with a 4 meters cable, but I extend it to 12 meters and it works perfectly. In terms of accuracy, I compared it with my professional anemometers brand TFA and Lacrosse, and the results were almost identical, which means that, at least in my case, the anemometer is factory calibrated. If there are any deviations, it can be easily fixed with a small modification of the code. And now let's see how the device works in reality. I will use this fan to generate airflow. Depending on the power supply voltage, we will also change the airflow. When switched on, the anemometer operates in test mode, and now all the diodes are switched on successively one by one to the maximum and then returned. After that, the device is started in dot mode and only one LED diode shows the value of the wind speed. Now we will turn on the fan and gradually change the airflow. If we press the button, the device switches to line mode and the value is displayed as line. When the wind speed reaches a certain speed, in our case 50 km per hour, previously defined in the code, a warning sound and light signal will be activated. Finally, the device is placed in a suitable box made of a PVC material with a thickness of 3 mm and the scale is drawn with a marker.